We had audio from all those.
What?
We had audio from this talk, so I'm trying to figure out what happened exactly. So sorry, 1 second.
No, you're good. Well, okay, maybe. My first full start was 2 years ago in Toulouse, and I had just did like a poster on this system, like presenting some very like good results. So
Hello. I think it's better now. I think it's better now. Yeah, sorry.
Do I just hold it or? Oh. Oh, okay. What you meant that one? I was like, this is super heavy, like it's crazy. Oh, it's too silky. Anyway, I'll just hold it. Okay.
So we're gonna get started. So my name is Caprice Phillips. She, her pronouns, and I'm a graduate student at the Ohio State University. Yes, we're advised to say it that way. And so I'm talking about a project I've been working on, the characterization of this BD plus 60 system with my advisors, Jackie and G, along with all of our wonderful collaborators. Let me just. Okay, shameless plug because I'd like to eat in the next 2 to 3 years. So I'm finishing grad students. I will be on the postdoc job market this fall. So this is a QR code to my website along with information about email. So I'm generally interested in all things brown dwarf, directly image exoplanets, host star abundances, and I'm also part of the leadership team for Black and Astro. And not to flex, but we got a recognition letter from the Vice President of the United States about our efforts with Black and Astro. So that was really awesome. So thank you. It was a wonderful surprise to get. So, but also do cool science in addition to this as well. Well, I hope you think it's cool. So. Okay, so before we begin my talk, I wanted to go through, brown dwarfs, as Elena said, to keep us all on the same page. So brown dwarfs, they cool as they age and they kind of progress through these spectral types of, into L, and T. I left out Y dwarfs. Sorry, coldest worlds. And so they go from warmer to cooler. And as they kind of transition through these phases, we start to see the emergence of different materials in the atmosphere, condensate materials like magnesium silicates and L dwarfs and observable photosphere to T dwarfs. They've kind of sunken beneath the observable photosphere. And this impacts the spectra and colors of these objects as well. So one of the things that I focus on in particular is L dwarfs, which is this BD plus 60 system. So just to introduce you, I want to introduce y'all to this a dusty planetary mass companion, the BD plus 60 plus 1417b. So this system was first discovered by Faraday et al. 2021 through help of citizen science efforts. So a little information about the system is that it is a companion to a solar type K0 host stars at a really wide, separation, and has an estimated mass between 10 to 20 Jupiter masses. And when this paper first came out, was really interesting is that they also showed that the spectral morphology or shape of the spectra resembled both directly imaged exoplanets and young low surface gravity L dwarfs. So there's a kind of a question of, does this object, this is a plot showing formation mechanism versus kind of masses for exoplanets, brown dwarfs, and stars. And so B plus 60 lies at this boundary between being a planet and a brown dwarf. So there's a lot of questions of, did it form more star-like, to low mass byproduct of star formation, or do you form more akin like a planet in a protoplanetary disk, more planet-like, for example? And some of the really interesting notes about this object, there's a really red object, and it joins a roster of
objects with an estimated mass less than 20 Jupiter masses, really wide separation, greater than 1,000 AU. And so probing and understanding, excuse me, the formation pathways via retrieval analysis, compositional analysis was some of the key aspects of this work. So I kind of wanted to walk y'all through, made this in Canva. I don't know if Megan's here, shout out. So I wanted to walk y'all through some of the main kind of questions and related to some of the things that we're working on for the system. So the first is, with Pepsi, we want to ask, like, how do the atmosphere of giant planets and brown dwarfs compare to the parent star? As far as like the formation as well, we want to look at the spin axis alignment of this system. We want to ask, like, what can we learn about the atmospheric composition in clouds of really red planetary mass objects, such as BD plus 60 via retrieval analysis? Then, excuse me, we want to also inquire about, is the companion variable, and is this variability driven by condensate clouds? So I have been reading the retrieval analysis with a code called Brewster by Ben Birmingham. And so we run into a lot of challenges in this really young, low surface gravity regime. So, and just a brief kind of overview, like in our retrieval analysis, we test 3 different thermal profile parameterizations. And regardless of which profile we test, we always find that our retrievals struggle to fit the K-band regions, which contains the CO band heads, for example. Oops. So another thing, I always joke to Jackie that I call this like a water slide profile. So this is a pressure temperature profile as we're going deeper into the atmosphere, and the temperature on the x-axis, and this is where it's trying to place the cloud on the right. So we see a very wiggly thermal profiling compared to the Sonora models, which we know this is not right. So, and we just for comparison, we expect a TP profile to look more like this from Voss et al. 2022, where we, go cooler, and as we go deeper into the atmosphere, we start heating up, not see these wiggles in the atmosphere, for example. And so just overall, we have challenges with the spectral fitting, we have endothermal profiles, and as a result of this produces really unreliable abundances, for example, which makes it impossible to calculate the atmospheric C/O ratio. Oh, bless you. Sorry, but alas, not all kind of getting down our news. So we also learned quite a few things, some key things from this retrieval analysis, for example. So what's really cool is that regardless of the thermal profile that we tested for BD plus 60, the cloudy models were always preferred over the non-cloudy models, which kind of is really like reinforced by the really red colors of this object. And so one of the things that's also kind of interesting that we've been doing, so Johanna Voss led this HST proposal with 10 hours of observing time to try to see if BD plus 60 was indeed variable. And so the answer is yes, hence the colorful variability and the variable title here. So this is what we're looking at, is the change in the flux versus time for both the entire wavelength coverage, and then some of the different channels where we have an amplitude varying from 2.3 to about 2.8 variability. For example, which also helps reinforce the idea that, this might be also driven by, patchy clouds, possibly in the atmosphere as well. And so another cool thing that we've been doing with this system is also, as EJ mentioned before, like it's important to also think about the host star as well. So Emily Calamari led some really great work using her framework from Calamari et al. 2024 to see what kind of clouds and different things and oxygen sinks we might expect from the in the companion based on the host star abundances. So this is some beautiful spectra from the Pepsi spectrograph. It's a high resolution optical spectrograph on LBT. This is a resolution of 50,000. And so this is just showing some of the like oxygen features, magnesium and silicate and aluminum, for example. And so we're able to get out C/O, magnesium to silicate, and calcium to aluminum. And we see a very enhanced magnesium to silicate ratio, as well as a subsolar C/O ratio for the host star as well. So just as a refresher, I wanted to excuse me, sorry, my throat just like dried all the way up. So sorry, I just wanted to kind of bring back this kind of this diagram and this ideas that we've been kind of thinking about to kind of characterize this system in a like a holistic thorough way. So we wanted to kind of see what we can learn about the whole star from the Pepsi spectrum. We wanted to see like what we can learn from the atmospheric composition in clouds of a really red planetary mass object, such as BD plus 60 via retrieval analysis. And we wanted to kind of inquire, is this object is this variable? And, is the variability driven by condensate clouds? So just a big red summary in your face is that it is a variable planetary mass companion, and the retrievals and the red colors kind of indicate there are clouds present in the atmosphere. And so the whole star abundances in theoretical framework predict force-ride and instacite clouds. And so I also wanted to give a plug to some of the continuing work I've been doing with the host star stuff. This is part of a larger sample to derive the abundances of the host stars to both benchmark brown dwarfs and wide binary system in a JWST proposal, as well as we have in our sample some host stars that are host to newly discovered brown dwarfs that are in Rothermich et al. 2024. And so this is some beautiful Pepsi spectra showing, the oxygen triplet in comparison to the sun for some of our sample. And so one of the things is that it's future and necessary work is that we simply need JWST data. I'm gonna put in two proposals, trying again, third time, maybe the charm, who knows? But we really need JWST data to really go after the clouds and understand this atmosphere holistically, to understand like the oxygen sinks and all kinds of different things simply with JWST as well. So I'll put up my conclusions and takeaways as I'm running out of time. Ooh, I need to go back. And then also I'll plug in that we'll be on the job market this fall season. So with that, I'll take questions. Thank you.
Have you, amongst all your people attempts to do a profile about TV, did you try to see your or what?
Oh yeah, fantastic water. So I'm gonna back outside, and I hope this is related to what you're saying. So one of the things that we did test was like free retrievals versus like chemical equilibrium. That's another thing that we did test. And so we saw that it has a more realistic pressure temperature profile, for example, and it did a better job at fitting the K-band region, but it wasn't preferred, statistically over the free retrieval. But that's something that we did explore in the paper as well.
Thank you.
Yeah, so I'm going to mention, so the bonuses were determined by Dr. Emily Griffith, and I'm working on the other sample with Megan Bedell. And so it was collected for non-LTE and LTE effects as well.
Everyone, give it to those that come to the front. We'll have 30 seconds, run through them, and then we'll break for coffee.
This is PowerPoint. It's PowerPoint. That's a PowerPoint. It's also a PowerPoint. So is it a Google Chrome?